तो हेलो हेलो गाइस वेलकम टू आशुतोष कोचिंग सेंटर। तो स्वागत है आपका आशुतोष के कोचिंग सेंटर में। तो आज हम लोग पढ़ने वाले हैं चैप्टर वेव्स के बारे में। ओके अब देखते हैं वेव में आता क्या है। पहले हमें पढ़ना है वेव मोशन क्या होता है। द मोशन ऑफ अ डिस्टर्बेंस from a one point to the another by the vibration of the what particles of the medium about their mean position is known as wave motion. Okay, it is a mode of transfer of energy from one point to the another. The wave are the mainly out of three types: mechanical wave, electromagnetic wave and the matter wave. वेव जो होते हैं इस टाइप के होते हैं। ठीक है, अब देखा जाए मैकेनिकल वेव क्या होता है। मैकेनिकल वेव exist only within a material medium, okay, such as material water, air and rocks. Example: water waves, sound waves, seismic waves. Okay, seismic wave, seis बोलते हैं ना seismic waves. Mechanical waves are of two types: transverse waves, longitudinal waves. अब वेव इक्वेशन क्या होता है ये खुद ध्यान रखना। डी स्क्वायर वाई बाय में डी टी स्क्वायर इज इक्वल टू वी स्क्वायर इंटू डी स्क्वायर वाई बाय में डी एक्स स्क्वायर, यानी कि डबल डिफरेंशिएशन। ट्रांसवर्स वेव मोशन क्या होता है? इट इज़ अ टाइप ऑफ wave motion in which particles of the medium are vibrating in a direction at a right angle to the direction of a propagating wave we have. The velocity of transverse wave vt is equal to root under t by m is equal to root t by में 2 पाई या फिर पाई आर 2p। वाइब्रेशन, इस फॉर्मूला को याद रखना। वेलोसिटी ऑफ ट्रांसवर्स क्या होता है? Vibration of the particles of the medium are normal to the all direction of wave propagation. Longitudinal wave motion, it is a type of wave motion in which particles of the medium vibrate in the direction of propagation of wave. The velocity of longitudinal wave v2 is equal to root e by p, magnetic momentum. A vibration of the particles are the parallel to the direction of the wave propagation. Electromagnetic wave क्या होता है? The electromagnetic wave do not require any medium for their propagation. All electromagnetic waves travel through a vacuum at the same speed c, and given by the c is equal to 29 यानी 299,792,458 meter per second. Example: light, radio waves, x-ray are all electromagnetic waves. Matter waves क्या होता है? Matter waves are the associated with the moving electron, proton, neutrons and other fundamental particles and even atoms and the molecules. Matter waves associate with the electron are employed in the electrons microscope. The wave on the surface of water. The waves on the surface of water are of two kind, and first is capillary waves and gravity waves. Capillary waves are the ripple of short wavelength, and the restoring force that produces the capillary waves is the form of tension of the water. Gravity waves क्या होता है? Gravity waves have the wavelength typically ranging from the several meters to the several hundred meters. The restoring forces that produce gravity waves is the pull of gravity, which tends to the keep the water surface at its lowest level. Okay, the wave in an ocean are a combination of both longitudinal and a transverse wave. Okay, अब traveling और the progressive wave क्या होता है? ठीक है, देखा जाए the wave which travel from one point to the point of the medium to the another is called a traveling wave. Displacement relation in a progressive wave at any point t, and displacement of wave traveling in the positive axis is given by the y is equal to under bracket x comma t, a sin ब्रैकेट में के एक्स माइनस ओमेगा टी प्लस फाइव। ओके, ये हमारा फॉर्मूला है और कोई दिक्कत बात नहीं है। जहाँ पे ए जो है एम्पलीट्यूड है और के जो है एंगुलर वेव नंबर और द प्रोपेगेशन कांस्टेंट है। डब्ल्यू तो जानते ही, ओमेगा जानते हैं। ओमेगा का क्या होता है? एंगुलर फ्रीक्वेंसी डिनोट करते हैं, मतलब फ्रीक्वेंसी कहते हैं। और फाइव जो है वो इनिशियल फेज ऑफ एंगल है, जहाँ पे ये जो के एक्स माइनस ओमेगा टी प्लस एक्स जो ये फेज ऑफ प्लॉट ऑफ फॉर अ वेव ट्रेवलिंग इन द पॉजिटिव डायरेक्शन ऑफ एन एक्स एक्सिस एट द डिफरेंट वैल्यू ऑफ द टाइम है। A wave traveling in the negative direction of x-axis can be represented by the y under bracket x comma t a sine kx omega t plus phi. एम्पलीट्यूड क्या होता है? एम्पलीट्यूड ऑफ अ वेव इज द मैग्नीट्यूड ऑफ द मैक्सिमम डिस्प्लेसमेंट ऑफ द एलिमेंट्स फ्रॉम देयर equilibrium position as the wave passes through them, and it is the positive quality, and even if the displacement is negative. Phase क्या होता है? It described as a states of motion as a wave sweeps through a string element at a particular position x. The constant phi is called the initial phase angle. Wave length क्या होता है? Lambda. It is defined as the distance traveled by a wave during the time particle in one vibration. It is the distance between two consecutive patterns in same phases. It is the distance between the two consecutive crest and the trough. The propagation constant of the angular waves number k for t is equal to 0 and phi is equal to 0. Y is the bracket x comma 0 is equal to sine kx. By the definition, the displacement y is same at the both end of this wavelength. This is at x is equal to x1 and x is equal to x1 plus lambda. Thus, a sine kx1, a sine k or under bracket x1 plus lambda is equal to a sine kx1 k lambda. This is the condition can be satisfied by only when k lambda is equal to 2 pi n. Okay, where n जो है वो 1 2 3 since they find as the least distance between the point with the same phases n is equal to 1. Therefore the k is equal to 2 pi by lambda. K is called the propagation constant or the angular wave number, or its SI unit is the radian per meter, yeah, or the radian per meter. Okay, रेड पर मीटर जैसे शॉर्ट में कहते हैं. पीरियड क्या होता है? द पीरियड ऑफ ऑस्किलेशन ऑफ टाइम टी ऑफ अ वेव इज द टाइम एनी स्ट्रिंग एलिमेंट टेक्स मूव्स थ्रू अ कंप्लीट ऑस्किलेशन. उसके बाद आता है एंगुलर मूवमेंट. तो पीरियड समझ गए ना? पीरियड क्या होता है? मतलब एक किसी टी टाइम ऑफ वेव का जो ऑस्किलेशन टाइम पीरियड होता है उसको वो किसी एनी टाइम पीरियड स्ट्रिंग के साथ एलिमेंट्स में मूव थ्रू अ कंप्लीट ऑस्किलेशन, मतलब कंप्लीट ऑस्किलेशन होने में जो उसका टाइम पीरियड लगता है ना, टाइम, उसको हम लोग क्या बोलते हैं? ये पीरियड. ओके, एंगुलर फ्रीक्वेंसी क्या होता है? द एंगुलर फ्रीक्वेंसी ऑफ द वेव इज गिवन बाय ओमेगा इज इक्वल टू 2 पाई बाई टी. द ऐसा यूनिट इज रेड पर सेकेंड. फ्रीक्वेंसी क्या होता है? इट इज़ द नंबर ऑफ ऑस्किलेशन पर यूनिट टाइम मेड बाय अ स्ट्रिंग एलिमेंट एज द वेव passes through it. The frequency v of a wave is defined as the 1 by t, and that and is related to the angular frequency omega by v is equal to half 1 by t, or omega or by omega by 2 pi. It is usually measured in the hertz. The displacement relation of a longitudinal wave. In a longitudinal wave, the displacement of an element of the medium is parallel to the direction of propagation of the wave. The displacement function of for a longitudinal wave is written as s bracket x minus x comma t and a sine under bracket x kx minus omega t plus phi, where the c s comma s bracket x minus x comma t is the displacement of an element of the medium in the direction of the propagation of the wave at the position of x and time t, and the speed of traveling waves. The speed of a wave is related to its wavelength and the frequency by the relation v is equal to omega by k and lambda by k, or the v by v. Okay, the speed is a कहते हैं द स्पीड डिटरमाइंड बाय द प्रॉपर्टी ऑफ मीडियम. उसके बाद क्या है? द स्पीड ऑफ अ ट्रांसवर्स वेव ऑन अ स्ट्रेच स्ट्रिंग. द स्पीड होता क्या है? देखो, द स्पीड ऑफ ट्रांसवर्स वेव ऑन अ स्ट्रिंग इज डिटरमाइंड बाय अ टू फैक्टर. फर्स्ट लीनियर मास डेंसिटी और द पर और मास पर यूनिट लेंथ म्यू, एंड द सेकेंड होता है टेंशन टी, वेयर वी इज इक्वल टू सी म्यू माइनस हाफ टी, एंड द हाफ और c is equal v is equal to c root under t by root m. Okay, mu, and it can be shown that c is equal to when with, therefore the speed of the transverse wave on a stretching string is v is equal to root under t minus t by mu. Okay, that the speed of a wave along a stretch idea string and depend only on the tension and the linear mass density of the string, and does not depend on the frequency of the wave. The speed of a longitudinal waves and the speed of a sound. In a longitudinal waves constitute of the medium oscillate forwards and the backward in the direction of propagation of the wave. The sound waves travels in the form of compression and the rarefaction of small volume element of air. The speed of sound waves depend on the first bulk modulus, second density of the medium. V is equal to C by root under B by B, where C is equal to क्या होता है dimensional constant and can be shown to be unity. Thus, the speed of longitudinal wave in a medium is given by V is equal to root under B by P. Speed of propagation of a longitudinal wave in a fluid therefore depend only on the bulk modulus and density of the medium. The bulk modulus is given by the B is equal to delta P and by the रूट अंडर डेल्टा भी बाई बी, यानी कि इसको स्ट्रेन कहते हैं. डेल्टा भी बाई भी इज इक्वल टू इज द फ्रैक्शनल चेंज इन द वॉल्यूम प्रोड्यूस्ड बाय अ चेंज इन द प्रेशर ऑफ डेल्टा पी. द स्पीड ऑफ साउंड एंड वेव इन अ मीटर ऑफ अ बार. द स्पीड ऑफ अ लॉन्गिट्यूडनल वेव इन द बार इज गिवन बाय द वी इज इक्वल टू रूट वाई बाई पी. ओके, इस फार्मूला को भी ध्यान रखना है, बहुत इंपॉर्टेंट फार्मूले है, बहुत आगे जाके काम आएंगे. वेयर पी इज द यंग मॉडुलस ऑफ द मटेरियल ऑफ अ बार. ओके, फिर इसको याद कर लेना. एयर का स्पीड क्या होता है, ये बहुत ज़्यादा ही काम का है. काम का नहीं कहो इसको, इसको वेरी वेरी इंपॉर्टेंट कहो. अब आता है न्यूटन्स फार्मूला. देखो कहाँ न्यूटन फार्मूला दिखाया, तो इन द केस ऑफ आइडियल गैस द रिलेशन बिटवीन द प्रेशर एंड पी एंड द वॉल्यूम वी इज गिवन बाय द पी वी इज इक्वल टू एन बी टी. ओके, एन के बी टी. ओके, देयर for isothermal change its flow that v delta p and p delta v is equal to 0, where minus p by delta v by v is equal to p and thus the b is equal to p. Therefore the speed of a longitudinal waves in an ideal gas is given by the v is equal to root p by p. Okay, capital P by small p, and this relation was the first given by the Newton and is the known as Newton's formula. ठीक है. अब लैपिस कॉरेक्शन क्या होता है. लैपिस कॉरेक्शन अकॉर्डिंग टू द, देखो लैपिस कॉरेक्शन दिया था हमने, न्यूटन जी ने दिया था. ठीक है, अब देखा जाए लैपिस कॉरेक्शन अकॉर्डिंग टू द न्यूटन्स फॉर द स्पीड ऑफ लाइट, फॉर द स्पीड ऑफ फॉर द स्पीड ऑफ साउंड इन अ वॉल्यूम, इन अ वॉल्यूम जो होता है ना 280 पर मीटर सेकेंड. एंड कहा जाए तो दिस इज अबाउट 15% smaller as compared to the experimental volume 331 meter per second. Replace Laplace point out the pressure variation in the propagation of the sound and waves are the adiabatic and not isothermal. Okay, for the adiabatic process the ideal gas satisfied the relation PV का पावर y इज इक्वल टू जो कहते हैं कांस्टेंट. अब ये जो क्या कांस्टेंट है डेल्टा पी वी वाई, जहाँ इसका वैल्यू था 0. तो फाइनली देखा जाए तो डेल्टा पी वी वाई इज इक्वल टू 0, तो डेल्टा भी प्लस डेल्टा वी वाई इज वी वाई प्लस वी वाई डेल्टा पी इज इक्वल टू भी 0 होता है. तो बी ए डी जो होता है वो भी माइनस डेल्टा पी बाय भी जो होता है वो भी वाई का पावर पी के बराबर होगा, वेयर वाई इज द रेशियो ऑफ टू स्पेसिफिक हीटेड एंड सी पी बाय द सी वी. ओके, ओके. Okay, the speed of a sound is therefore given by the v is equal to vp by delta p. Okay, मतलब सिर्फ p कहते हैं. This is the modification of Newton's formulas and referred to as Laplace correction. For air y is equal to 7 by 5, therefore the speed of sound is at stp we get value 331.3 meter per second. Okay, which agrees to with the measure of speed. The principle of superposition क्या कहता है? The principle of superposition of waves state that the net displacement at a given of a number of waves is algebraic sum of displacement due to each wave. Let y1 is equal to xt and y2 is xt. Okay, to be displaced at any element of the string and would experience if each wave travel along the displacement yxt of an element of the string when the waves overlap is given by yxt and yxt plus y2xt. And कहा जाए देखो let a wave traveling along a stretched string by the given y1 xt a sine kx minus omega t and another wave shifted from the velocity shifted from the first by the phase phi y2 xt a is equal to a sine kx minus omega t plus phi. Both the waves have the same angular frequency, same angular wave number, and k same wavelength, the same amplitude, applying the superposition principle. Yxt a sine kx minus omega plus a sine kx minus omega plus phi using the trigonometric relation. Omega is equal to root mgl by I yxt 2a cos half phi sine kx minus omega plus half phi. Thus the resultant of waves is also a बोलते नहीं है sinusoidal wave, and the traveling in the position direction of y x axis. The resultant wave differed from the constituent waves in two respects. Its phases angle is half phi, and the amplitude is the quantity given by a phi and is equal to 2a cos half phi. If phi is equal to 0, the amplitude of the resultant wave is a 2a, and which is the largest possible value of a phi. If phi is equal to pi, the two waves are completely out of phase. The amplitude of the resultant is to be 0. ओके इसको ध्यान रखना. अब देखो रिफ्लेक्शन ऑफ वेव्स क्या होता है. व्हेन अ पल्स और अ ट्रेवलिंग वेव्स इनकाउंटर अ rigid boundary to gets reflected, and if the boundary is not completely rigid or in the surface between two different elastic media, and a part of the media is reflected and a part is transmitted into the second media या medium कह सकते हो. ओके an incident and the reflected ray obey Snell's law of the diffraction, and the incident and the reflective waves obey the law of reflection. The The travelling wave and the rigid boundary or a closed end is reflected with the phase reversal. The travelling wave at open boundary is reflected without any phase change. A late incident wave is presented by the y1 xt a sine kx minus omega. Then for the reflection at a rigid boundary, the reflected wave is represented by yxt, and a sine kx plus omega t plus pi is equal to minus a kx plus omega. For the reflection at open boundary, the reflection waves is represented by yr xt a sine kx plus omega. Standing waves and the normal modes. The waves or the disturbance does not move to the either side is known as the stationary waves or the standing waves. Stationary wave और standing waves लगभग सेम होते हैं, इसको ध्यान रखें. Okay, let the wave traveling in the positive direction of x-axis be yxt and a sine kx minus omega t. The wave traveling in the negative direction of x-axis y2 xt a sine kx plus omega. The principle of superposition gives, and if the combined wave is yxt is equal to y1 xt plus y2 xt a is equal to a sine kx minus omega and a sine kx plus omega t. Okay, and is equal to 2a sine kx cos omega t, and the amplitude is 0 for the value of kx. That gives the kx is equal to, that gives the sine kx is equal to 0. The value given is by the kx is equal to n pi, for the n is equal to 1 2 0 1 2 3 4, and the substitution k is equal to 2 pi by n, and in this equation we get x is equal to n pi by 2, और is equal to n is equal to 4, n is equal to the 0 1 2 3 4 and so on. अब नोट्स क्या होता है. The positive of a zero amplitude is the standing waves are called nodes. Okay, मतलब बहुत सारे एम्पलीट्यूड मतलब स्टैंडिंग वेव्स होता है जिसको हम लोग नोड्स कहते हैं, पॉजिटिव नोड्स. अब देखा जाए द डिस्टेंस ऑफ अ पाई बाई टू द लेमडा बाई टू of half of a wavelength is separated by two consecutive nodes. The amplitude has maximum value of 2a, and which occurs for the value of kx and gives the sine kx is equal to 1. The values are kx is equal to n plus half and pi for n is equal to 0 1 2 3 4, and substituting k is equal to 2 pi by n. In this equation we get x is equal to n plus 1 by half. Okay, lambda by 2 or n is equal to 0 1 2 3. Antinodes क्या होता है. The position of the maximum amplitude are called the antinode. Okay, मतलब किसी ओके या तो कोई दिक्कत. And antinodes are the separated by the lambda by 2 and are the located at halfway between the pair of nodes. Standing waves or the stretch rings. Okay, for stretch rings, strings of the length L and fixed at both end and at the two end of the strings and have to be nodes. And if one end is chosen as a position x is equal to 0, and then other end is x is equal to L, in order that this is end is a node, and the length L must be satisfy condition L is equal to n pi n lambda by 2, and for the n is equal to 1 to 3. And standing waves on a string of the length of L have restricted wavelength is given by the lambda is equal to 2L by n for the n is equal to 1 2 3 4 etc. The frequency corresponding to the today's wavelength is given by the v is equal to nv by 2L for the n is equal to 1 2 3 etc., where v is the speed of traveling waves on the strings. The state of the frequency possible in a standing waves are called natural frequency, or the modes of the oscillation of the system. Okay, and so on. The frequency corresponding to the n is equal to 1, where v is equal to v by 2L, और कह सकते हो the oscillation modes, and with the lowest frequency n is equal to 1 is called the fundamental modes of the or the first harmonic. Okay, and the second harmonic is the oscillation of the modes with n is equal to 2, and the third harmonic corresponding is equal to n is equal to 3, and so on. The corresponding associated with these modes are thus often labeled as root 1, root 2, root 3, and the so on. The collection of all possible notes are the called harmonic series, and n is the harmonic number. Okay, यहाँ तक कोई दिक्कत? अब देखा जाए मोड्स ऑफ वाइब्रेशन ऑफ पाइप एंड द क्लोज एट वन एंड. द इन अ क्लोज पाइप स्टैंडिंग वेव्स आर फॉर्म्ड सच दैट अ नोड एट अ क्लोज्ड एंड and the anti end at the end at the end at the open end. And now id yani I had, and now id is the length of air column is L. Then the open and the x is equal to L and is an antinode. Therefore, the L is equal to n plus half lambda by 2 for the n is equal to 1 to 3. The modes which satisfied the condition L, lambda is equal to 2L n plus 1 half, and for the n is equal to 0 1 2 3, the corresponding frequency of various modes of such air column are given by v is equal to n plus half and v half L, and for n is equal to 0 1 2 3, the fundamental frequency is v by 4 L, and the higher frequency are odd harmonic, or the fundamental frequency is that is 3 root 3v by 4L and the 5b by 4L. Okay, अब देखा जाए तो पाइप ओपन एट बोथ एंड क्या होता है. In the case of pipe open at both end, there will be the antinode at both end, and at all harmonic will be generated. Beats क्या होता है? The phenomena of wavering of sound intensity when the two waves are of nearly same frequency and the amplitude traveling in the same direction are बोलते नहीं है superimposed. Okay, superimposed. Okay, of on each other is called beats. The beat frequency is given by the beat is equal to v beat is equal to v1 minus v2. Okay, अब आता है डॉपलर इफेक्ट. क्या होता है देखो, जानो क्या होता है डॉपलर इफेक्ट. डॉपलर इफेक्ट, the apparent change in the pitch of a note due to the relative motion between the source and the listener is called Doppler effect, and it was proposed by the Christian Doppler and tested experimentally on by the Bayes bulb. Okay, all type of waves are shows the Doppler effect when source and listener rest, and when the source and the listener at the rest, the frequency of sound heard by the listener and f is equal to v by lambda, where lambda is equal to v by f. When source and the listener moving in a direction, okay, हाँ, वेयर वी एस इज इक्वल टू वी एस जो है वेलोसिटी ऑफ स्पीड है, दस द अपेरेंट वेवलेंथ इज लेमडा इज इक्वल टू वी माइनस वी एस बाय हाफ, एंड द रिलेटिव वेलोसिटी ऑफ साउंड एंड विद द रिस्पेक्ट टू द लिसनर एंड वी इज इक्वल टू माइनस वी बाय वी एल. ओके, और देखा था द अपेरेंट फ्रीक्वेंसी ऑफ साउंड इज हेयर्ड बाय द लिसनर इज एफ इज इक्वल टू वी बाय लेमडा, एंड एफ इज इक्वल टू एफ वी माइनस वी डैश कैसे वी माइनस वी डैश एंड इंटू वी माइनस वी एस. ओके, अब देखो यूजेज ऑफ डॉपलर इफेक्ट क्या होता है. टू एस्टिमेट द स्पीड ऑफ स्पीड ऑफ सबमरीन plane, automobiles, etc. Okay, and to drop artificial satellite to estimate velocity and the rotation of star, and doctors used to the study and heartbeat and blood flow in the different parts of the body, and they use the ultrasonic waves and are in the common practice that is called sonography. And in the case of heart, in the picture generator, in the case of picture generator is called इनकार्डियोग्राम। ओके, क्या कहते हैं, इकोकार्डियोग्राफ, इसको ध्यान रखना। So guys, thanks for watching video till the end, and don't forget you are part of journey of needs. So like, share and subscribe करें. Bye bye, see you in next video.